Hey guys, so a question I get a lot is how I analyze chords and figure out how to call them. And I think I've came up with a really elegant method that really enabled me to explain the entire possibilities of all combinations of unique white keys and to reduce it to 19 chords. And today I'll show you actually how I do this harmonic analysis. It's a really cool and simple and I believe useful concept. So I suggest you follow through and feel free to ask questions. Okay, so how does it actually work? So take a look at this. This is just a whiteboard, and I'm going to take random sets of 4 notes, and I'll teach you how to do this. Okay, so here goes. Random sets. Okay, 1, 2, 3, 4, 5. I'll just stop. B, C, F, and E. Okay, and here's how I do it. It comes from a really basic assumption that was very helpful for me. And it works as the following. If I actually start on C and I write the notes, if I'll write C major like this, normally it'll be something like this. C, D, E, F, G, A, B, and in harmonic functions it'll be 1 and then suddenly a 9, a 3, 11, 5, 13, and 7. Right now I'm talking generally, so 7 means anything like major 7 or 7. Okay, which is interesting, but it doesn't really describe harmony that well. But if I repeat the process, but this time I write the scale out in thirds like this, C, E, I'm just going up 2 steps in C major constantly. C, E, G, B, D, F, and A. Okay, and again, I'll write down the functions. Look, it's kind of interesting. It really spells out the evolution of harmony because we're starting on just a 1, a 3, a 5, and a 7. It's almost like looking at the history of music, how we evolved from triads, 7th chords to tensions and beyond. 9, 11, 13. Okay, so that's like the... Okay, so take a look at that for a second. Okay, so 1, 3, 5, 7, 9, 11, 13 is what I call the harmonic tree because it's the collection of overtones. Let me play it for you so you get a good sense of how that sounds. That's just this thing. Okay, and really the chords get higher and deeper and more interesting as you add the tensions as opposed to just 1s or 5s. And then triads. And then 7th chords. And then the 9, 11, and 13s that we love in jazz. Okay, so it's basically a movement in the vertical direction where the chords get more complex, interesting, and cool. Okay, so here's how I actually perform the harmonic analysis, or how I figure out how to name any chord in the universe. Very useful concept. Okay, so here's how I do it. Now let's take some random inputs again. And remember, this is our harmonic tree. And when you look at it, look just at the bottom. Let me rewrite it for you. Now look at the harmonic tree, like something that starts on the ground. 1, 3, 5, 7, 9, 11, 13. And the whole idea is when you get a new chord that you don't know, let me just give you an example. For example, if someone asks me about the notes C, D, E, as a random example, okay, I'm sure it's a strange 3-note cluster. What I'll do is I'll analyze it 3 times, and I'll give each of the notes the opportunity to be the tonic. Okay, because I think the worst mistake you can make is assume that your lowest note is the root. Because when you play C major null inversion, nobody calls G, C, E. Nobody calls that, for example, G 11, 13, right? So it has no, doesn't really matter within an octave what order the notes are. It matters how the overtones interact. So I'm writing the three notes 3 times. And if C is the tonic, let me just move this just a second. So if C, there I go. Okay. If C is the tonic, then the other notes, then I have the 1, which is C. It's kind of obvious. And E is actually the 3. And D is actually the 9. Okay, so I'm placing it on this tree. So it points to the 1, the 3, and all the way up here, the 9. I'm trying to imagine what's the stablest chord I can make. The stablest being 1, 3, 5, for example. 1, 3, 9 is weaker, or 1, 5, 13 is weaker because basically I'm just measuring the distance from the ground. So 3 is 1 step above the ground. Imagine you have to climb this tree. 5 is 2 steps above the ground. And the furthest in the harmonic tree you have to climb is all the way 6 steps all the way to the 13. Okay, so if C is allowed to be king, we get 1, 3, 9. If D is allowed to be king, we'll get C, which is a 7 of a D chord, and E, which is a 9 of a D chord. Okay, so we'll have 1, 7, and 9. Okay, and if E is allowed to be the tonic, then we have C, which is 13, and D, which is 7. So we'll have 1, 7, and 13. And then I evaluate the possible chords that I'm making. And if imagine you have to climb on this tree, it's obvious that the chord called 139, the C, D, E one, okay, that little chord, is the strongest explanation, and in my mind, the C is the most fundamental vibration of these 3 notes. And in an idealized lab, if I were to play this chord and let it ring, no matter which inversion, I'm imagining that C will ring last because it actually can utilize the vibrations of the E better than an E chord can use the vibrations of C and a D. Okay, so that's the basic idea. You just pick your strongest chord, and let me just take you through some examples, and I hope the whole concept will be really clear. Okay? Okay, and what I'll do is we'll make some randomized 4-note samples, and of course I predict that you'll only get one of these 5 chords. You'll get 1, 3, 5, 7. You'll get X11, no 5, 9, which is 1, 3, 7, 11. You'll get X9, no 7, which is simply 1, 3, 5, and 9. And you'll get X11, no 7 and 9, which is really 1, 3, 5, 11, like a triad. Sometimes I call it X at 11. And you'll get X, 9, no 5, which is 1, 3, 7, 9. And the point of doing this process is you really end up with much, much less chords to learn and to practice. Again, only 19 chords in the entire diatonic universe. Okay, so that's the prediction. And now let's try to take some randomized chords. I'll just be clicking the mouse and I'll show you how I actually do the harmonic analysis. Okay, I'll be hitting it 5 times. 1, 2, 3, 4, 5. Okay, F, E, A, C. Okay, this is actually such a simple example because I can already tell it's F major 7. And nothing can be better than that, right? Because it's F, A, C, and E, 1, 3, 5, 7. Let's do something harder and then I'll show you. Okay, F, C, B, and A. Cool. Okay, that's an interesting enough example. F, C, B, A. Let me write it down and let's analyze it. Okay, so F, C, B, A. So what I'm doing is I'll be writing it 4 times. F, C, B, and A. And I will give F, C, B, each chord, each note, the opportunity to be a tonic. Okay, F, C, B, A, and F, C, B, A. And I'm predicting we're going to get one of the chords I've just shown you, the 5 atoms of the 4-note universe. Okay, so let's start. So if F is the tonic, okay, I'm not even going to write the 1. Let me circle it. In the world where F is tonic, we have A, which is 3, C, which is 5, and B, which is 11. Okay, 3, 5, 11. In the world where C is tonic, we have, let's see, F, which is 11, B, which is 7, and A, which is 13. So 7, 11, 13, very weak chord, 7, 11, 13. In the world where B is the tonic, we have F, which is flat 5. Remember, I'm in C major, so F is flat 5. We have flat 5. We have C, which is a flat 9, just a 9 in general, and a 7. So 5, 7, 9. Wait, that's correct? Let me think. Yeah, 5. 5, 7, and a 9. And in the world of A, F, C, B, A, I'm measuring the steps again, and I'll have, let's see, in the simplest order, I'll have B, which is the 7, C, which is the 3, 3 and 7, and 13, 3, 7, 13. Okay, and then I go back to my harmonic tree. Remember, 1, 3, 5, 7, 9, 11, 13. And I'm imagining what is closest to the ground. If I sum all the steps, for example, for 3, 7, and 13, I have to climb 1 step to the 3, and 3 steps to the 7, and all these steps to the 13. So the obvious answer in this case is this chord. The F, 11, no, 7, 9, or what we simply call F add 11. Okay, so that's one example. And because I know this, then I know how to play all inversions of these random collections. Okay, let's take another example. So you just practice how to actually do this. Again, I'm going to produce a random chord. I'm going to press, this is a random note picker, a wonderful site called random.brettpimental.com, which just produces any collection of notes you'd like. I'm clicking the button 5 times, 1, 2, 3, 4, 5. Okay, and I have E, F, C, D. Kind of an interesting example, I think. E, F, C, D. And again, let's practice the procedure. E, F, C, D. Okay. So again, writing it down. E, F, C, and D. Okay. Writing it 4 times. Assigning E as tonic, we get 9, 13, and 7, 3, 7, 13. Assigning F as tonic, we get 7, 5, and 13. Assigning C as tonic, we get 3, 11, and 9. 3, 11, and 9. 3, 9, 11. and assigning D as tonic, we get 9, 3, and 7, or 3, 7, 9. And the winner is this chord. The harmonic atom is called X9, no 5. Okay? If you want to hear it, it sounds like this. If you want to practice it, it's a lot of fun learning these things. Okay? And let's do a final example. I hope this is going to hammer the point home. Again, I'm going to press the button 5 times and get my random number. 1, 2, 3, 4, 5. Okay. F, C, B, G. Cool. F, C, B, G. Writing it down. F, C, B, G. Okay, let's allow F to be the tonic. We have a 5, 11, and a 9. 5, 9, 11. Allowing C to be tonic, we get 11, 7, and 5. 5, 7, 11. Allowing B to be tonic, we get 5, 9, and 13. Allowing G to be tonic, we get 7, 11, and 3. 3, 7, 11. And of course, the winner, I will practice making beautiful arrows urgently. The winner is this G7, and the atom is called that's X11059. Hold on, let me erase that. X11, no 5, 9. It has these inversions. Okay, again, very interesting sounds. Let me get back to my face, say hi to you all. So the idea is that you reduce any input of random notes in this method. I explain all this on collections of 4 notes, but it works very well, for example, on intervals. If I do, for example, thirds, C and E is just 1 and 3. And it's very easy for me to move chords when I know this. If I do fourths, for example, C and F, it's very easy for me to see that the notes C and F in C major spell out the 5 and the 1 of an F chord. So there are only 3 possible chords when you do inversions, only 1, 3, 1, 5, and 1, 7. So you basically use harmonic analysis like a knife to reduce the amount of possible chords to the strongest chords, and then you start to see that all kinds of collections of notes are just inversions of the same chord. Okay, so that's how the concept works. I have quite a bit of content on my channel, how I use this stuff using melodic shapes, all kinds of interesting intervallic ideas and harmonic ideas. So I hope this clarifies this really frequently occurring question. And if you'd like to support me, support I really need, you can definitely like, subscribe, share, or take $25 introduction lessons that are introductions to my world, which I believe can really do incredible things for guitar players. So thanks for watching, and I'll see you next time. Bye-bye, guys.